You can continue.
Okay, so good evening, everyone. So as I said, today we will be looking on Etabs modeling of a building. So today's classes will be handled by Mohammed and me, Junior Engineers Structural Department. And Mohammed will be giving an introduction classes on Etabs software, and I will be handling the rest of the sessions. So Mohammed, you can take over.
Thank you, Neha. Good evening, all. Today, we'll be discussing about ETABS. So, first of all, we know for a building modeling, we need to design various elements of a structure, that is beams, columns, slabs, likewise. So, we need to first model and then apply the loads and to analyze the building. So, today we will be learning how to model a building. And in the previous classes, you all have learned about different types of loads which will be acting on a building, and also how to draw a BC layout. I'll be sharing the screen now. Can anyone respond if you can see my screen?
Yes. Your screen is visible. You can continue.
Okay. There are many softwares used for analysis of building, like there are STAD, ETABS, STAB. We here will be using ETABS for modeling and analysis. Okay, now the introduction. Etabs, the full form of Etabs is Extended 3D Analysis of Building System. It is an engineering software used for analysis and design of multi-story buildings. It has an inbuilt library for concrete, steel, and composite sections, which we'll be seeing. And for example, many of the tall skyscrapers buildings will be is modeled using ETABS, and it is owned and licensed by CSI Computers and Structures Corporation. And there are two methods of for drafting or modeling a building using grid spacing or importing DXF file, which we will be explaining later on. So first of all, I will show you the interface when we open the ETABS. This is the interface will be coming when we open the software, and here we have to click new model, and there they will ask some of the details like which country and which IS code we need to follow. Basically, because I have already used ETABS in my laptop, they will already automatically show me Indian and all the IS code which we use. But when you guys open it, maybe it will be according to American or British codes. So you can select according to the place and the type of code we want to use. Okay. And this is another function which will be appearing. Here we need to draw the plan of the building first to the ETAP software. So here either we can easier method will be to import the DXF files for the of the building plan to the ETABS directly from the AutoCAD, or otherwise we can just, this is the DXF method we can use to import to the ETABS, which Neha will discuss later on. I will show you just roughly how to import the floor plan of the ETABS of a building to the ETABS using grid system, which is much difficult and which can only be used when the building is in a symmetrical shape. So this is we use custom grid spacing, and then we use edit grid data. And according to the room sizes, we will provide dimensions in the X and Y directions. And when we changes the X coordinates here or Y coordinates, you can see there is a small column here, you can see the live plan of the building. So if I'm changing 6, well, I think here you can see the one more floor or one more room is added here on, and likewise we can change the Y data also. This is the ordinate method. We can also choose spacing, like if we know the size of the building, say 6 meter is the size of the building in next direction, we can directly put 6 meter. And if the next size of the room is 4 meter, then we can choose 4 meter. Likewise, we can provide the spacing of the rooms or the dimensions of the rooms in the X and Y directions and enter click. And now we have already now we have drawn the plan of the buildings, let's say, and we need to provide how many number of stories are there for the building. It is a G+2 building or G+3 building. Say if it is a G+2 building, number of stories of 3 will be given, and a typical story height of, let's say, 3.1, and a bottom story height of, say, 2 meter for foundation. Okay. Here, the building grid system is formed, but we have not drawn any of the framing of the building, that is beam, column, slab is not drawn, but just the grid system is drawn now. So we can now edit the grid system by right clicking, and here you have the option add or modify grids. And here you can add or you can just name the all the stories like ground floor, first floor, terrace. Likewise, we can modify the grid system also. Grid can only be used, it's not only, but preferably it can only be used when the building is very symmetrical and easy planned. But when there is irregularity, like unsymmetrical floors are there, it is better to go for the DXF file import, which Neha will shortly explain to you guys. Okay, now we have drawn the grid system. Now we need to draw beams, columns, all those structural elements. For that, we need to define the beams. That is beam we need to define the sizes of the beams, columns which we need to use. But before that, we need to define the material properties we are going to use. Like what kind of what properties of concrete are we going to use, or what properties of steel we are going to use in our building. So we need to define the material properties, define material properties. So here there are inbuilt properties here, but it is based on other countries. So we can use add new materials. India, first we will define steel. First we will define concrete. We can choose the mixed grade of the concrete we are going to use. I am going to use M25 now. M25, okay. You can just click on OK. These are inbuilt properties. So M25 mixed concrete is defined now. So now we have defined the concrete properties, and next we need to define steel properties. Add new material. We go for rebar. Indian HYSD 415 and 500 is there. So we go for 415 and 500. Both steel properties will be defining. Okay. Okay. Will be defining HYSD 500 also. Okay. Now we have defined the properties of the materials we are going to use. Now we need to define beams, columns, slabs, etc. So these coming under the section properties. First, we define the material properties, and below that we have section properties. Here you can see frame sections. tendon, slab, and if I have a retaining wall, we can define by choosing wall sections. First, I need beams and columns, which will be coming under frame sections. So here are some of the inbuilt columns and beams, which are some of them are steel. So we need add new property. Click on add new property. Here you can see in this interface, we can choose what kind of beams or what material of beams or columns we are going to use and which all shapes are available. As you can see in concrete, we can choose for a rectangular. Maybe you can choose for a rectangular column or circular column likewise. And in also steel also, we can use for I section, that is ISMB section or ISMC channel section, tube section. Likewise, you can pipe section. And also you can also go for steel composite section as per our requirements. And also if we need, let's say, two ISMC sections or with the build-up sections, we can design our own section using this option section designer, which is a higher application of Etabs. And now we will be defining beams and columns in rectangular concrete section. Here, this interface is coming. And now we need to name. First, we will be giving a minimum width of beam, a minimum width of 200 mm for beams. So we will start on beam 200 by, let's say, a depth of 300. First, the depth of beams can only be decided after analysis and finding if the beams or the other elements are safe or not. If the loads acting are not satisfied, if the loads acting cannot be held by the section we are providing, we need to increase the depth of the section. So that can only be found out after analysis. So I will be starting with a 200 by 300. In some of the cases, beam can go up to 600 or 700 as per our needs. And even the width of 300 or 400 can be used. We can design as per our needs. We go for M25. Now we have chosen the type of concrete. We have given the type of concrete, the material of concrete we are going to use for the beam. Now we need to choose the type of steel which we are going to use in these beams. And before that, we need to change the depth 300, dimensions of the beams 200. And here there is an option called modify or show rebar. When you click on it, here it will be in default, it will be coming on column section. We need to choose beam. And we need to choose a longitudinal bar of HYST of 500. Confinement bars also 500. And a cover of 48 mm will be given. Click on OK. Now beam 200 by 300 is defined. If we need to define a 200 by 400 or 200 by 500, we can simply click on add copy of property and give the name 200 by 500 or 400. Now I'm giving 400. The same options will be the same. The previous selected options will be existing there because we clicked on add copy of the property, previous property. Okay. Now we have defined two different sections of beams. Now we need to provide column sections. Add new property. For a residential building, we can provide a column width of 200 as minimum. But when it comes to commercial or high-rise buildings, according to the code, we need to provide at least a 300 mm dimension. So column for a residential building, let's say 200 by 300. Likewise, what we did on the beam, we need to give concrete properties, change the dimensions, and modify or show rebar. We need to the column is it is as it is now. Longitudinal bars, confinement bars, HYST 500. We need to change the dimensions of the longitudinal bars plus 16 and the confinement bars as 8. Because 20 is very, very heavy material, so we only need to use 16. Okay. Now column is defined. Okay. Now we have defined beam, column, and next we need to define slab. So define section properties. Here there is slab sections. We will start the slab with a depth of 110 mm and a concrete material of M25. Only after designing according to the load coming on the slab, we can design the depth of the slab. Maybe it can reach 120, maybe 130. It depends on the dimensions of the slab we are going to provide. So here thickness will be changed to 110. Okay. Now we have defined the different elements in a building. Now we need to define different loads which will be acting on the building. As you guys have already discussed by Suresh sir, the type of loads which will be acting on a building. Can anyone tell me some of the few examples of the loads which will be acting on a building? There are different loads which will be acting on a building. If anyone can say. Okay, there is a live load, dead load. Then there will be wall load, which will be acting on beams. Wall load will be given as a dead load, and its self-weight multiplier will be changed to 0. Only dead load have a self-weight multiplier as 1. Add new load. Wall load is defined now. Next, we have parapet load, which will be coming on the roof slab, which will be also coming under dead load. Add new load. Now we have floor finish on the slabs we are going to apply. So floor finish short for FF. It is also same as dead at new load. Now if we have water tank above the building, like usually water tank will be provided on the roof of the building. So we need to define water tank load. It is coming under live load at new load. And if we have a lift on the building, like if it is a G+3 or G+4 building, lift is a must. So lift will be there. So we need to provide lift load also, which is also coming under live load. Now we have already defined live load here, but we usually here give live load. We usually divide live load into two types, like live load less than 3 and live load greater than 3. So live load less than 3 and live load greater than 2. Now we need to provide sunken loads for the toilets. Which is also coming under dead, self-weight 0. Now, some of the other main loads which will be coming are earthquake loads and wind load. So earthquake in the both earthquake and wind load, it can be acting upon two directions, that is X and Y direction. So I will be giving earthquake load first, EQ, and X in X direction. I will denote it as EQX. Type seismic, and we need to choose the IS code, and that is IS 1893-2016 at new load. Likewise, earthquake acting upon on Y direction EQY, seismic, same code at new load. Now we have wind load WLX acting upon X direction. Type is wind. There are different types of loads here. We have seismic, snow, freeze press. It varies upon our needs. But here we need only earthquake and these many loads. So wind, the codal provision for wind load is Indian IS 875 2015, which is latest than 1987. So 2015 at new load. WL wind load active upon Y direction. IS code at new load. Here we need to edit some of the, we need to find the loads of EQX, earthquake and wind load according depending upon the codal, that is the according to the site the building is standing on, based on the wind speed and the zone of the earthquake. In India also, there are different zones coming under seismic. For us, it is zone 3. So according to it, we need to provide all these data according to the code, which will be discussed later on when we discuss about the loads on a building. But here in EQX, we can untick all other options here. Only X direction will be chosen. Okay. Likewise, in EQY, X direction will be unticked. Only Y direction will be ticked. How these loads are coming will be discussed later on in the upcoming classes. Likewise, in wind load also, we need some data to input for proper loading, which will be discussed later. So we have defined the loads which is acting on a building, different types of loads. Now we need to provide load combinations. The analysis of the building is based on the load combinations. That is, on not the dead load or live load is not going to act independently. So it is going to act upon in a combined way. So we need to give combinations of loading. Here there is a default design combinations. Here define load combinations. Add default design combinations. Here you can see concrete frame design, and you can choose this option, convert to user combination. So we can edit later on if you want to. Click on OK. There will be 26 combinations, but as I forgot to click on OK, all the combinations were not added. Okay. I forgot to click OK. So all those loads were not saved. Here, if we come to the load combinations again, there are 26 combinations for us for the analysis of the building. Now, Neha will be discussing about how to import a DXF file from the Etabs after drawing the center line in the plan or the BC layout of the building. Neha,
Okay, thank you, Mohammed.
does anyone have any other doubts? You can ask. I will clarify them now.
You can just raise your hands if there is any doubt.
Any doubts in defining the loads or the properties or the sizes of the beams or columns? I believe no one has any doubts. I'll be handing over the class to Neha now. Thank you.
Okay. Okay, thank you, Mohammed. Okay. So next we can see how to convert a drawing to DXF file so that we can import into Etabs and model a building. So here we can see this is the architectural drawing. I have already drawn the beam column layout here. So in order to draw or in order to convert a drawing file to DXF file, we need to get the center line of this beam column layout. So here I have taken the beam layout separately. So I need to get the center line of this beam layout. So for that, I will be using a command. To draw the center line, I will be using a command called multi-line command. This you have already learned in your first class of beam column layout. So using that command, I will be drawing the center line of this beam layout. So I'll be drawing center line like this. I will be picking each and every point. I'll be drawing center line in every beams. So I have drawn the center line. So when we look into this portion, you can see that the center line has not coincided. That is, the center line has not joined with this center line. Likewise, there are many points in same cases. And here, when you look, the center line has overlapped, has extended after the meeting point. So I need to clear all these corrections, all these type of errors. So for that, I'll be selecting this center line drawing, and I'll be moving here. And in order to edit this multi-line, I need to explode this multi-line first. So I'll be exploding this multi-line, and after that, I'll be clearing all these errors. So using extend command, I can extend these lines. You need to check thoroughly on each and every point to check whether if all the lines are extended, all the lines are joined correctly. Likewise. So here I am extending all the lines. Here there's an extension. So I'll be trimming this. Here I need to extend this line. So using extend, I will be extending these lines. So it's almost okay. Almost all the points I've extended. And next I need to trim the extra lines. Like this, I'll be trimming all the extra lines. So here, when we look into each and every portion, every intersection, all the central lines has connected. They have gotten enough connection, and This is okay. So next, I only need the central line in order to import into the Etabs. So for that, I'll be selecting this central line alone from this beam column layout. So for that, I'll be using an option called quick select. So using this quick select option, you can select the line by using its property like color, layer, line type, etc. So here I need the central line which is in yellow color. So I need to select that yellow color line alone. So for that I'll be using the quick select option. In that properties I will be selecting the color. So the color of the central line which I need is yellow. So I'll be selecting the yellow color and I'll be clicking OK. So the line with yellow color has been selected. So here there is also a line with yellow color, but this was not selected because this is a multi-line. And if we need to select that line, we need to explore that multi-line. So that's why that yellow line was not selected. And if we look into this AutoCAD drawing here, there are many other selections with yellow colors. So I only need the central line drawing. So I will be deselecting all the other selections. And after that, I will be moving this central line from here to here. So here I have extracted the central line. So next we can thoroughly check whether if there is any connection. Yeah, here it was not extended. And here also it was not extended. Likewise, check all the points whether the connection is okay. So it's almost ready. So next, after extracting the central line alone from the beam layout, we can do two corrections. The first correction is purge option. So purge option. So for that, we'll be selecting this and we'll be clicking the purge option. So here I'll be checking the purge checked items. Purge all checked items. So purge items will help you to remove the unused items like block definitions, layers, etc. So that was the first correction that should be done. The second correction is the overkilling. So overkilling is done in order to delete the overlapping lines. As the name indicates, overkilling is used to delete the overlapping lines so that we can avoid errors. So here I have done both the corrections and I have got the corrected central line. So next I need to change the central line into DXF file. So for that, I'll be adding a new AutoCAD. And from here, I'll be copying this central line and I'll be pasting this to the next AutoCAD file. So in this AutoCAD file, there is nothing other than the central line. So I need to save this drawing file to DXF file. So for that, I'll be clicking here, choosing the option Save As. We can give a file name, says DXF file. And we can change the file type to DXF file. So I have changed the file type to DXF file and I have saved that file. So this is the method of converting a drawing file to DXF file. First, I have drawn the central line of this beam using the multi-line command. And after that, I have extracted the central line alone. And after that, I have done the both corrections. And after that, I just copied to a new drawing file and then just saved it as a DXF file. So that's the step to convert a drawing file to DXF file. So the next step is to import this DXF file to Etabs. So for that, I'll be opening the Etabs. So this is the first interface when we open the Etabs. And to import the DXF file to the Etabs, we will be selecting File and here Import and from here DXF file of floor plan. So I'll be clicking that and here there is a file which I have saved now, DXF file. So I'll be clicking and opening it. So the new tab has opened and we need to input some details. So here beams and this PDF cast means the layer which that beam had in that drawing. After that, DXF file unit is in mm. So I have drawn that in mm and beam properties. So we will be starting using 20 by 40 or 20 by 30 beams. So here I have given 20 by 40 beams. Next is the column property. So as I said, for a residential building, we can start with a 20 by 30 or 20 by 40 column. But as per IS code, for a building, the column sizes should be 300 by the width of the column should be 300. So this is a residential, small residential building, so that we can start it by using 200 by 400, that is 20 by 40 column. And next is the floor properties. So floor properties means the slab sections. So normally for a residential building, we will be providing a slab of thickness 110. So Mohammed has already taken classes how to define the depth or how to define the section properties of slabs, beams, and columns. So after that, we can define each and every thickness of a slab. So I will be selecting as a starting iteration. I will be selecting a slab of 110 mm size, and story level will be ground floor. That is the base floor. After that, you can click OK. And now they will be asking to save this Etabs file. So you can save this Etabs file as Etabs 123 or something. You can give the name that you like. After that, after saving, this plan will be imported. So this is how you can import the DXF file to a AutoCAD, to a Etabs. So here I have previously imported certain files. So that has come. Actually, when we import a file, it will be coming at the ground floor. Here, since I have already opened the Etabs and it was in all stories, when I import a file, that file will be get imported in all the stories of all the defined or default stories. So we need to change this option as one story, and so that only the ground floor beam layout will be imported. So here I have drawn the center line for the ground floor beam, and that ground floor beam has imported. Next, we need to add the story heights. So when you look into this plan here, there is two architectural drawing, that is the ground floor and the first floor. So we have three beam layout levels, that is beam layout for the ground floor, beam layout for the first floor level, and beam layout for the terrace floor level. So there will be three beam layout for this particular architectural drawing. So we need to add the stories. So for that, we will be going to edit stories and grid system, modify show story data. So here we can edit the number of stories, edit the story height, etc. So here by default it is base, ground floor, first floor, and terrace. That is ground floor beam, first floor beam, and terrace. Base is the bottom portion of this level. So say if this architectural drawing consisted of a second floor plan too. So we will be having four levels, that is the ground floor, first floor, second floor, and the third floor. So we can add second floor here. So in order to add the second floor here, we can right click here and we can select add story, keep story existing height, and we can a new tab will be opened, and for here the first one is the story height. So we need to enter the floor to floor height. Say the floor to floor height of that residential building is 3 meter. And next option is to enter the number of added stories. So say, as I said, consider there is an additional second floor. So we only need an additional one floor. So you'll be entering the letter one, number one, and next insert the story above. So here, as I said, I need a story above the first floor. That is, I need a second story which is above the first floor. So I need to add a new story above the first floor level. That is, I need to add the second floor level above the first floor level. So I'll be dropping down this and I'll be choosing first floor. Insert the story, insert above story first floor. So the next story which I am going to add will be coming automatically above the first floor. Next one is the replicate new story. So I don't need to replicate any of the stories. So I will be choosing none. Okay. So as you can see, a new story is added above the first floor. So I can give the name second floor. So likewise, you can add any number of stories as you wish. So say if I like I said, I considered there was an additional story, so I added an additional story here above the first floor. So coming back to our architectural plan, we only have ground floor, first floor and terrace. So I don't need this second floor. So I can delete, by clicking here, I can delete that story, delete existing story. So this is the option of adding and deleting the stories here. After that, we can enter the details of our architectural plan. So we can enter the height. So corresponding to ground level, we will be entering the height of the foundation. So say if you are providing footing for this particular plan. So if you are providing footing for this particular residential building, normally we will be providing a height of 2 meter. So say if we are providing pile foundation to this particular building. So for pile foundation, the height from base to ground floor will be normally 10 times the diameter of pile or the 5 meter. So consider we are providing footing here. So we'll be providing the value 2 here. And the next corresponding to first floor, the height that we should enter is the height between the ground floor and the first floor levels. So consider the height between the ground floor, the floor to floor height is 3 meter. So we'll be entering the height as 3 meter. And same for the terrace floor. Consider the first floor to terrace floor height is 3 meter. So it's 3 meter. After entering the height which we need, we will be refreshing the view and we will be clicking OK. OK. So the levels are added. So now let's check whether the levels have come correctly. The first one is the base, which is at 0 meter, which is at the bottom level. And the second one is the ground floor, which is at the 2 meter level from the base. The first floor is 5 meter from the base. The second floor is 8 meter from the base. That is 3 meter height for story and 2 meter for the base level. So the levels have came here. Next, we need to apply or add the beams for the next level. I have imported only ground floor beams. So I need these beams in first floor and terrace floor. So for that, I'll be replicating this. I will be selecting all these beams. There is an option shortcut for replicate. You can also use shortcut Ctrl+R in your keyboard, or you can go to edit, replicate. So in this, you can replicate these beam to the first floor level. So for that, I'll be selecting all the beams. I'll be selecting story. I need this beams in the first floor. So I'll be selecting first floor here and I'll be applying. So when you look into this, you can see in this first floor, the beam has been replicated. So I need the beam in this terrace floor too. So for that, I'll be selecting the beams again. I need this beams on the terrace floor. So I'll be selecting the terrace and I'll be applying. So as you can see, the beams have replicated in all the 3 levels. That is the terrace floor, first floor and the ground floor. So now we can just add a story. Add a new window to view the 3D plan. So here, this is a 3D plan. You can see, you can rotate it like by pressing the shift key, you can rotate this and view it. So I have imported the ground floor, the first floor and the terrace floor. So the next thing is to place the columns. I have imported beams. So these center line represent the beams. So next one is to next point or next option is to import the columns or place the columns correctly. So for that, we need to look into the beam column layout, and in this beam column layout, we need to keep an eye. We need to place these columns correctly as per beam column layout, and we can look wherever we can place the column. So here I have the columns are placed in these positions, and we can add the columns in that particular positions. So in order to place the column in correct position, we need to check the architectural drawing too. So after that, to place the column, there is an option called quick draw columns. So here at this left point, there is an option called quick draw columns. We need to click that, and there will be a new tab opened at the bottom portion. So we need to select the size of the column. So there will be different size as defined already in the Etabs. So we need to select the size. Say I am selecting the size of 20 by 40 column. After that, I can place these columns correctly. So there was a column here. There was a column here at this portion. You can just look into Etabs and you can place the columns correctly. So now, when we look into this AutoCAD drawing, this column is positioned vertically. This column is positioned horizontally. So in order to change the axis of the column, we can change this angle / degree to 90, and then we can place the columns, rotate the columns like this. So now we can place the columns. So this is how we will be placing the column. So in this 3D view, we can see that we can see that the columns and beams which you have imported and which you have placed are correctly set. And this is how this 3D model looks. So I think the time is over. So the balance classes will be continued in the next week. So today we have just introduced Etabs and just introduced how to convert a drawing file to DXF file. And I have told how to import this beam and how to place the columns correctly. So the balance will be, rest of the session will be continued in your next session, that is next coming Thursday. I'll be explaining it once more. So is there any doubts till here? Anyone? Okay, thank you.